Your next coding interview question might be, given an array of integers and an integer sum value, return the indices of the two numbers such that they add up to the sum value. So in this example, given an array 1, 3, 4, 2 with sum equals 7, I would return 1, 2 since 3 plus 4 equals 7, and 1 and 2 are the indices of those numbers. Can there be more than one way for an array to reach the target sum value? There is only one way in which two numbers in the array can make the sum value, and the same element cannot be used more than once. Is it possible for a given integer array to not have a solution to the sum value? It is not possible for the input array to have no solution. Should the returned indices be returned in a certain order? Got it, the indices can be returned in any order. What naturally comes to mind is to check possible pairs of each element that can reach the sum value. In this example, we would first iterate to the first element 1 and subtract 7 minus 1 equals 6. We'll then have to go through the array again to check if there is a 6 to pair with a 1. This requires a double for loop to check all possible pairs of each element. This is not an efficient algorithm as it will result in n-squared runtime, since it requires checking each element more than once. I'd like to explore how I can bypass checking each element more than once. The spatial complexity of the brute force solution is constant because we are using the original input to check the value. A potential approach is to make a trade-off in memory to improve runtime. It seems reasonable to use a hash map to store an index and element value. Creating an entry to a hash map results in constant runtime, but storing in a hash map will result in linear spatial complexity. Here's what I'm thinking. I'll iterate through the array and check if the sum minus the element is in the hash map. And then if the value does not exist in the hash map, I'll add the current element in the hash map. The hash map would have a key being the element and the value being the index. If the value does exist in the hash map, I'll return the current index and retrieve the index of the subtractive value from the hash map. Let me validate my code. It works! In summary, I'll use a hash map to store the element value and its index. For every iteration, I'll check if subtracting the element by the sum value produces an element value that can be found in the hash map. If not, I'll add the element to the hash map and continue checking. Here's my code.